Compiler and interpreter. A compiler and an interpreter are two different types of software programs used in the field of computer programming. They both play a crucial role in translating and executing source code written in high-level programming languages into machine code that can be understood and executed by a computer. However, they differ in how they accomplish this task. Compiler. A compiler is a program that translates the entire source code of a program into machine code before execution. It takes the source code as input and generates an executable file or object code as output. The compilation process consists of several stages, including lexical analysis, syntax analysis, semantic analysis, code generation, and optimization. During these stages, the compiler checks for errors, enforces language rules, and produces optimized machine code. Once the compilation process is complete, the resulting executable file can be run independently of the compiler. Advantages of compilers. Compiled programs generally tend to execute faster as the code is pre-translated into machine code. The executable file generated by a compiler can be distributed and executed on any compatible system without the need for the original source code or the compiler itself. Interpreter. An interpreter, on the other hand, is a program that reads and executes the source code line by line, translating and executing it simultaneously. Instead of translating the entire code before execution, an interpreter processes each statement or instruction, one at a time. The interpreter parses the code, performs necessary operations, and directly executes the corresponding machine instructions. Advantages of interpreters. Interpreters can provide immediate feedback by executing code line by line, making them useful for debugging and testing. They often offer more interactive and dynamic environments, allowing for rapid prototyping and experimentation. Interpreters can be more flexible in handling runtime errors since they can stop execution at the point of error and provide detailed error messages. In summary, compilers translate the entire source code into machine code before execution, while interpreters execute the code line by line, without creating an independent executable file. Each approach has its own advantages and considerations, and the choice between a compiler and an interpreter depends on the specific requirements of the programming language, the target platform, and the goals of the programmer. Computer buses. Computer buses are communication pathways or channels that allow various components within a computer system to exchange data and signals. They serve as physical connections or electrical conductors that enable the transfer of information between different hardware devices, such as the CPU, memory modules, storage devices, expansion cards, and other peripherals. Buses provide a standardized method for data transfer, allowing different hardware components to communicate efficiently and effectively. They define protocols, data formats, and electrical characteristics that ensure compatibility and reliable communication between devices. Here are some common types of computer buses. System bus, also known as the front side bus, it connects the CPU to the main memory and other major components on the motherboard. It carries data, control signals, and addresses between the CPU and memory. Address bus. This bus carries memory addresses, which are used by the CPU to specify the location in memory for read or write operations. The width of the address bus determines the maximum amount of memory that can be addressed. Data bus. The data bus is responsible for transferring actual data between the CPU and other devices, such as memory or peripherals. Its width determines the number of bits that can be transferred in parallel, also known as the bus width or data width. Control bus. This bus carries control signals that coordinate and control the operation of various components in the computer system. It includes signals for memory read and write operations, interrupts, clock signals, and other control functions. Expansion bus. These buses are used to connect expansion cards or peripherals to the motherboard, allowing additional functionality to be added to the computer system. Examples include peripheral component interconnect, PCI Express, and USB buses. Serial bus. Serial buses transmit data sequentially, one bit at a time, over a single wire or a pair of wires. Examples include universal serial bus, serial ATA, and Ethernet. Parallel bus. Parallel buses transmit multiple bits of data simultaneously over separate wires. They were commonly used in older systems, but have been largely replaced by serial buses due to limitations in speed and complexity. These are just a few examples of computer buses, and different computer architectures and systems may have variations or additional types of buses depending on their specific design and requirements. Buses play a critical role in facilitating communication and data transfer between the various components of a computer system, enabling its overall functionality. Thanks for watching the video, and subscribe the channel and hit the bell icon for watching our next video.